Back again, and in this session we are going to continue with the first order. Okay, with the first order and first degree ordinary differential equation. And in the previous session we have completed 6 questions, and in this session we are going to begin with the new questions. So the question which we are going to take will be of good levels, because this is going to be the last session on exact differential equation type questions. So the question is as follows: solve 3y 3 e power 3xy minus 1 plus bracket 2y e 3xy plus 3y square x into e 3xy into dy by dx. So what you have to do, you have to just multiply this d here. Okay, so what you are going to get after simplifying? You are going to get something like 3y cube e power 3xy minus 1 dx plus 2y e power 3xy plus 3y square x e power 3xy into dy should be equal to 0. Now comparing the given equation with which equation we are going to compare? M of x comma y d of x plus n of x comma y dy equals to 0. We get m of x comma y as 3y cube e power 3xy minus 1. First thing, n of x comma y 2y e power 3xy plus 3y square x e power 3xy. Now to check whether it is exact differential equation or not, we need to get dm by dx, dm by dy. So if we do the differentiation of this with respect to y, what we are going to get? Firstly we are going to this will become 0. So our main target is to simplify this one. Okay, so what we are going to do, this is y cube. So firstly we will use product rule first thing. So we will keep y cube as it is, e power 3xy will be as it is, and then by chain rule this will be 3x, right? After this, what we are going to do, we are going to do the differentiation of this. So it will be 3y square e power 3xy, right? And if we simplify further, what we are going to get is, if we take 3 outside and e power 3xy outside, we are going to get 9 e power 3xy outside, and we are finally going to left with x y cube and y square, right? Similarly, let's move on to the next page. If we move on to the next page, what we see, we need dou n by dou x. So here dou n was what? If you observe this in this one, we are going to differentiate, so only this term will be differentiated, but in this product rule will be used. Okay, so twice the terms will be differentiated. So let's differentiate it. So first thing, 2y e power 3xy into 3y firstly. Next we are going to take the y1, which will give me 3y square. Okay, if we differentiate the x, this term will be gone and I will be left with 3xy. But if I differentiate next time with respect to e power 3xy, I am going to get this only 3y left. So finally, if I see this thing and this thing are same, and this thing also has 3 power xy common, so what we are going to left with? We are going to be left with, let's see, let's just simplify. 6y square, right, e power 3xy plus 3y square e power 3xy, and lastly 9y cube e power 3xy. Okay, so this is what 9y square e power 3xy, and here 9y cube e power 3xy. So if we take are we doing any mistake or what? Here n of x comma y is what? N of x comma y is 2y e power 3xy, right? 2y e power 3xy, and this one is 3y square e power 3xy. So when we differentiated the first one, what we are getting? 2y e power 3, and here we are getting 3y. This one is correct, but in this 3y square the x will be gone because there is only one x, and y square e power 3xy will be left. And in the next, what we are going to get? 3x square 6xy square. Okay, if we take only there are total 3 terms, right? Y cube, here we are getting y cube. Here there will be one x term also. Okay, so here there will be one x term also. So if we take 9 e power 3xy common, we are going to be left with y square plus xy cube, right? So we came to conclusion that dou m by dou y is equal to dou n by dou x, right? After this, what we have to do? We have to say, so the given differential equation is a exact differential equation, so its solution is given by, how will the solution be given by? The solution will be given by y constant m of x comma y dx plus integral terms of n of x comma y free from x. See, let's substitute the values. What we are going to get here is, we are going to get something like, if we substitute the values, we are going to get, here it will be m of x comma y. If we observe what it was, m of x comma is 3y square e power 3xy minus 1, right? So let's substitute 3y cube e power 3xy minus 1 into dx. Now let's check in this integral terms free from x. So this one, okay, this one, okay, this one has x, so it is not free from x. Here there is x, here also there is x, so there is no term. So 0 dy should be equal to c. Now if I solve it, what I have finally, what we are going to get, we are going to solve this one, which will give me, since y is constant, so it will be as it is, and e power 3xy, if we integrate, I will be left with 3y, and here minus x, and this one will be 0, and here it will be constant. So if I simplify, I am going to be left with y square e power 3xy minus x equals to constant. So this is our answer. Hope you have understand each and every step. Now let's move on to the next question. So the next question which we are going to take is as follow. The question says solve what 1 plus 2x under root x square minus y square dx minus 2y under root x square minus y square dy should be equal to 0. Therefore comparing the given differential equation with what I am going to compare, m of x comma y equals to dx plus n of x comma y dy should be equal to 0. Therefore and n of x comma y this is our m of x comma y and this is our n of x comma y. Now we need to find dou m by dou x. You know this will be 0. You just need to get this. So if you go with the here it is y. So this will be constant. So 2x upon twice under root x square minus y square into minus 2y, right? 2 will cancel out and you will be left with minus 2xy the whole upon under root x square minus y square. Okay. Now dou n by dou x. Here if you see, this will be again constant and 2 under root x square minus y square will be there, and here 2x. Since we are differentiating with respect to minus 2xy upon under root x square minus y square, we will get again. Therefore we can say is equals to, now so the given differential equation is the exact differential equation. So its solution is what? X constant, so if I substitute the values, what we are getting? We are going to get m of x comma y, which is nothing but if I substitute 1 plus 2x under root plus if you observe here n of x comma y, here there is no terms, okay, which is free from x, because it is what there inside there is x. So what we are going to write, integral 0 dy should be constant. So if I integrate, what I am going to get is nothing but x, this will be as it is. Now the integral will move in that thing, which is nothing but 2x under root x square minus y square dx plus 0 equals to c, and here y constant. So if you know one thing, we will use substitution, which we used to do in class 12, x square minus y square equals to t, then 2x dx is equals to dt. So you can make out that x dx is nothing but dt by 2. So we will substitute this x dx. Okay, so we are going to left with under root t, y constant, x will be as it is into dt by 2. So we can call it dt only, because there is 2x dx, right? So we can call it dt equals to c. And if I simplify, this whole part is integration, okay, which you learn in class 12. And if we solve it, we are going to take 3 by 2, the whole upon 3 by 2 equal to c, which is our answer in the final step. And finally, I resubstituted the value of t, which gave me this answer. Therefore, hope you have understood this problem properly, because in the end the integration part was difficult, rest of all was easy. Now let's see the next question. So the next question which we are going to take is as follows, which says solve. What we have to solve, x dx plus y dy is equals to a x dy minus y dx the whole upon, right? Okay, where a is constant. So what we are going to do in this problem, whenever these kind of things are appear, as I mentioned you, whenever you get something structure like this, okay, dy are present, you need to collect the terms. You need to collect the terms. Don't get into hurry and multiply. Multiplication is done when you get dy by dx upon something like something, okay, like in that we are getting some ratio, okay, they were separated out. Here we need to first collect, and then we will reach to that condition, okay, if such thing happens. So first we will collect the terms. Now we will move this y this side and move this x this side. Here it will be a. There will be no x square, y square. Okay. So if we move here, we are going to be having plus ay. Sorry, I just did a mistake. Okay, sorry for that. Here it will be x, and here it will be plus ay the whole upon x square plus y square the whole dx plus y minus ax the whole upon a square plus x square dy equal to 0. Now if you observe, we got the thing into m of x comma y dx plus n of x comma y dy equal to 0 format. So comparing with comparing with, we get m of x comma y. What is m of x comma y? M of x comma y is nothing but x plus ay y square, y minus ax a square plus x square. Further on, what we are going to see is dou m by dou y. It will give us what? If you observe, this will be 0 because we are differentiating with respect to this. So now you have to use the quotient rule. A will be there, minus ay will be as it is, and here x will become 0 again and 2y will be there. So what you are getting here is nothing but ax square plus ay square minus 2ay square, the whole upon x square plus y square the whole square, which will give you finally ax square minus ay square the whole upon x square plus y square the whole square. Now we are going to use dou n by dou x, which will give us what? If I use dou n by dou x, we are going to get something like where was dou n? Okay, so here this will become 0 and minus will be outside, so we are going to differentiate this. Okay, sorry, here it will be y square, here it will be y square, right? I don't know why we put here a square. Now it is correct. So y square plus x square the whole square will be there, and this is outside, okay, minus x square plus y square will be there, and here what we are going to have is this minus ax. If I differentiate, a will be there because minus we have taken outside, minus sign ax into 2x close. Finally, what we are going to left with? We are going to left with final thing, which is ax square ay square minus 2ax square the whole upon x square plus y square the whole square. So finally minus ax square plus y square so therefore the given differential equation is a exact differential equation. So its solution is, how we will get the solution of this? Using that formula which was integral. Constant, let's substitute the value and see what we are getting. So finally we are going to left with x plus So here there is only one term of y. You can directly make out from this equation, which was the, okay, there is only one term which is independent of x, which is this y term. So we just substituted that. Now it's up to you how you want to integrate it. It's up to your skills. So first it's x square by 2, which is very simple to integrate. Now ay is constant and you know that integration of 1 upon a square plus x square dx is nothing but 1 by a tan inverse x by a. So we will use this, and because of which we are going to get it will be, here it should be x and here it should be a, right? So what we are going to get, if we do this, what we are going to get is 1 by y, right, into tan inverse x, like here x by a, so x by y. After this we will integrate this y square by 2 and this constant. So we are done with this, and this is our answer. Hope you have understood each and every step. Now the last question which we are going to do is this question. Let me change the pen. So the last question, pen has some bug or what. So the last question which we are going to take is as follow, that solve what, e power minus x square plus y square bracket x dx plus y dy should be equal to 0. What you have to do in this type of problems, multiply it. Okay, if you don't multiply, then okay, you will get stuck. So x e power minus x square minus y square into dx plus y into e power minus x square minus y square dy should be equal to 0. Comparing the given differential equation with what equation? Zero. We get what? M of x comma y is nothing but x e power minus x square minus y square. N of x comma y is nothing but y e power minus x square minus y square. So finally, if we do this will be of no use, x, because we are differentiating with respect to y. So our final thing which we are going to get, it will be as it is into, this will become 0, minus x square will become 0, minus 2y will be the thing which will be left. Similarly here, dou n by dou x, y will be of no use, minus x square minus y square at the top will be as it is. Here minus 2x will be left and y will become 0. Finally, minus 2xy e power minus x square minus y square we are getting from this side, and here minus 2xy e power minus x square minus y square we are getting from this side. Therefore, is equal to dou n by dou x. Therefore, the given is a exact differential equation. Therefore, after knowing this that it is an exact differential equation, so its solution is given by, how is this given by? This is given by y constant. m of x comma y dx plus integral terms of n of x comma y free from x equal to constant. If we substitute the values and see what we are getting, let's substitute the values. What we have as m of here y constant. So what we have m of, it is x e power minus x square minus y square, right, into dx, and here we have 0 dy. You can clearly make out there is only one thing from the first also you can make out. So if we do one thing, let's take minus x square minus y square, x square plus y square is t. So we are going to get 2x dx is equals to dt. So x dx is nothing but dt by 2. We can substitute this thing in the given equation, which will give me finally our equation will be modified as y constant e power minus t into dt by 2 equal to c, because that 0 will become, this will, when integrated, will become nothing. Finally, if I integrate this, 1 by 2 will be as it is, e power minus t, and its differentiation will be minus 1. And finally, it is equals to constant. Now we will resubstitute and check what we are getting. So 1 by 2 with minus sign, e power minus t was x square plus y square. After substituting, this is our answer. So hope you have understand properly exact differential equation type question. So from the next session we will begin with the type 2. Till then, practice all these problems of exact differential questions, and in the next session we will start with the new things. Don't forget to subscribe the channel, okay, so that we can bring more engineering content for you guys. Thank you.